In a car, the source of electric current is the battery. After the horn has been fixed and the battery is properly connected again, it permits us to have light, heat, and power. The starter motor is run by electric current from the battery. We can also use house current to get light, heat, and power. But house current is too dangerous to experiment with. Instead, we'll use the battery. We have connected some of the same things to the battery that are connected to it in the car. Headlights, a horn, and a starter motor. We've also included this meter. The meter indicates whether or not there is electric current in the circuit. When the needle in this meter points straight up, the meter reading is 0. There is no current in this circuit now. Why isn't there? The answer, of course, is here. There is electric current only when the electricity has a complete circuit to flow through. Now the electricity has a complete circuit to flow through. When the circuit is broken, no electricity flows through it. When there is an electric current, the meter shows it. By completing the proper circuit, we can cause electricity to flow through the headlights, or the horn, or the starter motor. But can we really see anything flowing through this circuit? Here is something that we can see flowing. And here is a meter that indicates when water is flowing through a pipe. The meter reads 0 when the flow of water is stopped. What happens if we turn on another sprinkler too? Now there is more water flowing through the pipe and the meter reading is higher. If we turn on another sprinkler, the reading is higher still. When you turn something on in this circuit, the meter shows a reading. Turn something else on too, and the meter shows a higher reading. This meter acts like the meter measuring the increasing flow of water. This is one piece of evidence to suggest that there is something flowing through these wires that acts in one way at least like water flowing through pipes. If something is flowing in this circuit, it must go out here and come back here, or the other way around. Let's say for the sake of argument that it flows out through here, along the wire through the meter, making it give a reading, through the closed switch, through the headlights, making them light, and back along the wire to the battery. In other words, for the sake of argument, we're saying that electricity flows out from this post of the battery and flows back in to this post. If what we've said is true, now the electricity is flowing out from here through this wire through the headlights, through the switch, through the meter, making it show a reading, and back to the bat. Yes, the meter shows a reading, but in the opposite direction. Reversing the wires doesn't seem to make any difference to the headlights. They light with the wires in either position. But look what it does to the meter. The meter shows a reading when the wires are attached either way, but the reading is in one direction when they're like this, and in the other direction when they're like this. There is a similarity between the way the water wheel acts and the way this meter acts, which suggests that both are being acted upon by something that flows. In the one case, water; in the other case, electricity. Between this battery and these headlights, there are several thousand feet of wire. When the switch is closed, the circuit will be complete. Let's assume that when the circuit is completed, electricity will flow from the battery out through this wire, through the headlights, and back through this wire to the battery. If this were true, we might suppose that this meter would kick over before this one. After all, the electricity would have to go through all the wire before it gets to this meter. Let's try it and see. No, as far as the eye can see, both meters kicked over at the same time. What does that mean? Here is a loop of clear garden hose. These meters will kick over when water flows through them. When this pump is turned on, it will pump colored water from this container out through the circuit of hose. These two meters didn't kick over at the same time. The water flowed through this one first, and then through this one. Now the hose is full of water. When we turn the pump on now, water will move everywhere in the circuit at just about the same time. And the meters kick over at the same time. Why do these meters kick over together? We could explain it in the same way by assuming that whatever it is that's flowing in this circuit is already in the wires. The battery would be acting in somewhat the same way as a pump. The wires like pipes that are already full of something that can flow. The stuff in the wires that can flow is called electric charge. When something pushes electric charges and makes them flow, then there is an electric current. We'll look at another piece of evidence that goes to prove that the electric charges are already in the wire. This meter will kick over when electric charges flow into it. When electric charges reach the piece of gold foil in this gadget, the foil will move away from its support. That doesn't prove the electric charges were in the wire. They could have come from the battery. This is a plastic coat hanger, and this is a silk scarf. You've probably observed that rubbing things can sometimes cause electrical effects. Somehow, the rubbed coat hanger is making electric charges move. But the coat hanger doesn't touch the wire. The electric charges must already be in the wire. The coat hanger pushes electric charges into the meter and onto the foil leaf. When the hanger is removed, the electric charges flow back. When something pushes charges and makes them flow, you have an electric current. Don't think that electric charges are found only in such things as wires. We believe today that electric charges are in all materials. We believe that any material in the universe has electric charges in it, and there's lots of evidence to back that up. Don't try this yourself unless you use a weak battery. There is electric current in this circuit. Electric charges in human bodies are being pushed by the battery and made to flow, causing an electric current.